Welcome to the video tutorial for the chi-square test of statistical independence. This is actually one of the simpler techniques that we cover in the course, but maybe one of the more useful techniques for undergraduate researchers. Essentially, the chi-square test is a statistical test that allows you to display information in a cross-tabulation or a contingency table, essentially the same thing, and test whether or not the difference between the expected values in the contingency table or the cross-tabulation and the observed values in the contingency table or cross-tabulation are different enough to show some degree of relationship between the two variables. So what we're essentially testing for here is to see if two variables are related based on the difference between their observed and expected values within that table. Now, if that sounds complicated, it's really not, because what we're looking for is simply enough evidence to see if something leans one way or leans the other, or if it's just random. So in that kind of situation where it's just random, the relationship is not statistically significant, there's really nothing going on there, it's not particularly interesting, it's not really what we're looking for, but sometimes that's what we find. But it's nice to know. So let's begin actually by looking at the assignment for this time. In the exercise related to this tutorial, I'm asking you to please complete an essay that uses the chi-square test of independence to test a theory regarding differences related to race using the data set Unit 5 data. What I'd like you to do is come up with a general theory about some issue related to the concept of racial differences in opinion. So as you can see, the first variable that's listed here in this particular set of data, and this is an excerpt from the GSS from 2014, the General Social Survey we talked about before. What I'd like you to do is test some difference between racial groups on some social issue or some issue of opinion and see if there's a difference there. I'd like you to test 3 of those and have them be on some general theme, whether it's economics, whether it's social issues, whatever it is. There are a lot of things to choose from here. As you can see, I've given you, aside from the race variable, about 100 or so variables to work with that are all possible to use with chi-square. And in order to figure out exactly what those variables are, you can just go ahead and review the variable labels. The variable labels, they'll give you an idea of what you're dealing with here. So I'm going to walk through the assignment testing a theory and some hypotheses of my own to show you how it's done. And then you can follow along, see how the technique is done. It's quite simple, and you'll be able to do it for whatever you're interested in. So my particular issue is going to be the issue of abortion, and to see how racial differences play into differences of opinion about abortion, or if they simply don't make any real difference. So my general theory is this, that based on race, there is some difference in opinion about a woman's right to get an abortion for a variety of reasons. So some difference exists based on race regarding abortion. It's my general theory. Okay. The 3 hypotheses I'm going to test, you can see they're right here at the top of this list, is I'm going to test a hypothesis that says there's a difference between racial groups in their opinion about if a woman should have an abortion for any reason. That's my first one. If a woman should have an abortion, should be allowed to have an abortion if there's a strong chance of a serious defect. And my third one, if the woman's health is seriously endangered. All right, let's start with that first hypothesis regarding abortion if a woman wants it for any reason. Formally, we would say the null hypothesis here is that no relationship exists between race and opinion on this question. All right? So how would we test that? That's a pretty straightforward process of making a cross tabulation and including a test statistic, the chi-square test of statistical independence, to see whether or not any statistically significant relationship exists. So let's check it out. Go to Analyze, Descriptive Statistics, Crosstabs. Now, in the crosstab box, I generally like to stretch it out a little bit so I can read the labels. I'll want to add in my row variable, and make sure it goes in the row variable because you're going to be reading percentages across the row. I'm going to put my race variable there. Now, for purposes of the GSS, there are only 3 categories for the race variable. It's white, black, and other. Not particularly great in terms of how they've broken it down, but it's what we have to deal with, so that's what we're going to use. Now, in the column variable, I'm going to find abortion if the woman wants it for any reason. Put that in the column. Now I need to click on a couple of these tabs over here. The first one is statistics, and I want to pick chi-square. Chi-square is our test statistic in this case. It, by the way, has the same alpha level, the same required p-value as all of our tests have in the past, and that's 0.05. So we're looking for a result that is 0.05 or lower for statistical significance. So hit continue. Then I want you to go to cells, and this is something I want you to pay attention to. We are very interested in our study here at looking at the differences between races. So when we look at this, we want to make sure that the way we read the table makes comparable sense in terms of the amounts in question. So in order to make reasonable comparisons between responses within the groups, so we can compare them between groups, what we really want to do is just click on the row percentages. And what we'll be able to do is read across the responses and see how the responses vary by percentage by race. We use percentages because obviously the groups are going to be of different sizes, but we want to see how they compare to one another in the way they break down on the issue. So once you've checked the row percentages, hit continue, and we're back to our regular box, and hit OK, and you'll get output that looks like this. Now there are a couple of different things here. There's the case processing summary that just tells you how many cases you had and how many were actually used and how many were missing, that sort of thing. Convenient thing about crosstabs and chi-square on SPSS is they drop all the non-responses automatically, so you don't have to worry about that at all. So let's see what our actual results were here. And this is our for real, honest to God, cross tabulation. And what it's done is break down each of the responses, yes and no, by racial group. So you can read it like this. 45.2% of white respondents said a woman should be able to get an abortion for any reason, and 54.8% said no. You can tell this is read across as a row percentage because it totals 100 in the row. Handy rule of thumb. Now, among black folks, 45.9% said yes for any reason, and 54.1% said no. And the other category, meaning Asian, Pacific Islander, Native American, whatever other group they've lumped in there together, is 43.7% yes and 56.3% no. So you can see there are some small differences there between those groups, and here of course is the total, where 45.1% said yes of all respondents said yes, and 54.9% said no. You can see there are some small differences between the groups, but looking at it, it doesn't seem to vary that much. But how can we tell for sure? Pretty simple. We look down here for the two-sided significance of the Pearson chi-square, right here in this first row of results on the table, and this is 0.8 0.97, way above that critical value of 0.05. So this result essentially fails to reject the null hypothesis because there really isn't that much of a difference between the observed and the expected values. There certainly isn't much difference between the racial groups. Right, so in this case, we would fail to reject the null hypothesis. We really can't say if any difference exists. So we would say no relationship, fail to reject the null hypothesis. Okay, let's try another one. Clicking back on our SPSS program, go to Analyze, Descriptive Statistics, crosstabs, replacing abortion if the woman wants it for any reason with, excuse me, let me clear that out. Replacing the abortion if a woman wants it for any reason with a strong chance of serious birth defects. We can look back here, we'll still see that chi-square is checked. As in cells are the row percentages. Hitting OK again. What do we get? Once again, reading across here, we get 76.6% of whites say yes, a woman should be allowed in the case of serious birth defects, and 23.4% saying no. You can read down here. 71.7% of black folks say yes, 28.3% say no. And in the other group, 72.6% say yes, and 27.4% say no. So looking at the chi-square test, Pearson's chi-square with a value of 3.576, 2 degrees of freedom, and an asymptotic significance of 0.167. The p-value of 0.167. Way above, again, our critical value of 0.05. In this particular case, we failed to reject the null hypothesis. It seems that in this case, no relationship exists between race and opinion on abortion, meaning that opinion doesn't vary based on your race in a way that's significant enough to matter. You can see there are some small practical differences, but nothing that rises to the level of statistical significance. All right, let's try our last one. Analyze, Descriptive Statistics, crosstabs, clearing out this cell, and replacing it with if a woman's health is seriously endangered. Our statistics, chi-square, remains the same. In the cells, the row percentages remain the same. Hitting OK. What do we get? So what do we see here? We see white folks at 88.6% saying yes and 11.4% saying no. We see black folks at 90.4% saying yes, if a woman's health is seriously endangered, she should be able to have an abortion, and 9.6% saying no. And in the other group, that catch-all group, 81.5% saying yes, but 18.5% saying no. So there seems to be some more noticeable variation between the groups. Let's check our Pearson's chi-square. Pearson's chi-square, value of 8.838, 2 degrees of freedom, and a p-value of 0.012, below our critical value of 0.05. In this case, we reject the null and say some statistically significant relationship exists between race and opinion on this question. I think it's pretty easy to spot here. you see that this in the other group is really different than the other two groups. It doesn't give us much of an explanation for why, but there does seem to be some difference here. So, looking at this, I can say generally, based on these three questions, little difference exists among racial groups regarding their opinions on these three abortion questions, with the exception of serious health concerns. No difference was found to be statistically significant. All right, so your mission is to find three related variables that you can house together, that you can lump together under a general theory, test the hypotheses related to those variables based on differences between racial groups, and write a little story about it for me. You'll find the specific instructions in the assignment on Canvas and in the unit instructions if you need a different copy. All right, as always, if you have any questions, please feel free to contact me. Good luck with the assignment.